Okay, here we go. So we are doing 5, 6, and 7 now. So we have a circuit that's in parallel, and we have a 17.5 ohm resistor, and we have a 22 ohm resistor in parallel. Remember, when we have two resistors in parallel, they have to have the same voltage. And if they're in parallel with the battery, then that has to be the same voltage as well. Okay, so I'm writing in the resistances, 17.5, 22. Okay, again, we had 49.2 volts is the voltage. So that means everywhere at the two resistors, everywhere else in parallel. So 49.2 here and 49.2 there. All right. Now, what we need to do is we need to find out the equivalent resistance of a parallel circuit. The equivalent resistance is going to be using the equation. You can't just add it up. Okay, so it has to use the equation 1 over R total is equal to 1 over R1 plus 1 over R2. I say equivalent or total, I say them the same thing. So 1 over R total is equal to 1 over R1 plus 1 over R2. You don't just add them up. It's not a series circuit. You have to have them in that equation. All right, so we have the 1 over 17.5 plus the 1 over 22. Now we could do like lowest common denominator, which would be a huge pain in the butt. We don't want to do that, but we have good calculators, so we can cheat. What we can do instead is we can just start with parentheses, okay? And we can do the fractions inside. So I start open parentheses in my calculator and do 1 over the 17.5, and then I do 1 over 22. I'm going to close parentheses and put to the -1. And that will get me the right answer for the equivalent or total resistance of the whole circuit. And I plug and chug, and I'm going to get a number that's like 9 point something. Let's see what we get. 9.78, something along those lines. Slowly, 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 we're getting it. Let's see. 9.78, whatever. So there are 746. So that's the answer to number 5. Okay, so there's your equivalent resistance for the whole circuit. Now, the next part is we need to figure out the current running through the battery. And the current running through the battery is just going to be Ohm's law, V equals IR. You can use the Ohm's law for an individual resistor or for the entire circuit. So in this case, we're going to do it for the entire circuit. So if we're looking for a current, we're going to take the total voltage of the battery, 49.2, and we're going to divide it by the total resistance of the circuit, which we just figured out was 9.746. Okay, so we're going to get those two together. We're going to divide it out, and we're going to get a number somewhere around 5. Okay, so we'll get it, plug and chug, 49.2 divided by 9.746, and we get our answer, which is going to be, waiting for it, 5.05. So there we go. There's our answer to question number 2. Okay, question number 3. Now we want to know how much current is running through the 17.5 ohm resistor. Now, what we're going to do is we're just going to take again, we can use Ohm's law for just an individual resistor. So we do Ohm's law, V equals IR. We know the voltage for the individual resistor was still 49.2. We know the resistance was 17.5. So all we have to do is divide it out, and we'll get our resistance. 49.2 divided by 17.5, and we'll get our current of 2 point something. Okay, quick note. So the total current was 5.05. We got our current of this one to be 2.8. So if we did 5.05 minus the 2.8, we get the current going through the other resistor as well. Okay, that's it.